All right, in this podcast, we're going to talk about predicting the products of chemical reactions. There are a few steps we can follow to help us do this. First, we want to identify what type of reaction we have based just on the reactants. Then we're going to switch, combine, break apart, whatever the reaction calls for, the products as appropriate. We'll swap and drop charges if needed. Then we'll balance the equation and use our solubility rules to determine the states of matter. We're going to start with a couple examples of synthesis. All right, we have K and I. We know in synthesis that they are coming together. And if we remember from our 1 plus 2 plus 3 plus skip, 3 minus 2 minus 1 minus zip rhyme, K is in the 1 plus and I is in the 1 minus. So when they combine, we must swap and drop charges. They're both 1, so they would cancel out. Okay, so here's our equation. We do need to check the number of atoms on each side, though, so we can balance. So that'd be 2, so we can have 2 I's, but that also makes us have 2 K's. Then we'll need to put 2 there to get that balanced. Okay, so at this point, that's the balanced equation. All right, the next example, we also are dealing with synthesis. Okay, now we have a BA, which is in the 2 plus column, and a S, which is in the 2 minus column. So again, these charges cancel. We end up with BAS, and we have, when we balance, we see that we have 1 and 1 and 1 and 1. So it's already balanced as is. Okay, SR and N2, remember that 2 is there because N is a diatomic element, one of those that can never be by itself. All right, SR and N. SR is 2 plus, N is 3 minus, so when you swap and drop, you get SR 3 and 2. Okay, all right, now we have to balance the equation. So we have SR 3 and 2 and 2 and 1. So we need 3 SRs on this side, and then we have a balanced equation. All right, the next example, we have 2 diatomic elements here. We have H and Br, 1 plus, 1 minus, swap and drop, and they end up just being HBr. And then when you balance your equation, you'll have 2 and 2, 1 and 1, so you'll need to put a 2 here, and that will take care of both of them for you. Okay, all right, this one you have Na 1 plus and N3 minus, swap and drop, you get Na3N. Okay, now when you balance the equation, you've got 1 and 2 and 3 and 1. So I'm going to go ahead and get those N's straightened out. It's going to give me 6 NAs. So I'm going to need to put a 6 there. And now I'm all balanced out. Okay, so that's how you would tackle synthesis. All right, now we'll look at decomposition. In decomposition, they're breaking apart. So calcium is going to break off by itself. It's not diatomic, so I can leave it as is. And then F breaks out. F is a polyatomic, not a polyatomic, but a diatomic, so I'd need to put F2 to make sure that it is stable. All right, we got LiH. So Li is not a diatomic, H is a diatomic, so I'm going to have to put that 2 there. So then when I go to balance my equation, I had 1 and 2 and 1 and 1. Had to put that 2 there. That gave me 2 Li's, so I'd have to put a 2 there. And that previous equation was already balanced. Sorry I didn't count them. All right, another decomposition example. You have H and O. H is a diatomic, and so is O. So you'll need to put 2's beside them. And then when you go to balance the equation, you have 2 O's on this side, give you 4 H's. Oops, kind of wrote off the page there. And 2 O's, so you're going to have to put a 2 there to make your H's balance out. Okay, all right, then we move on to single replacement. All right, single replacement is a little more tricky because you have to know which one will replace which. So you need to go ahead and figure out their charges before you even go swapping and dropping. So Ca is 2 plus, Br is 1 minus, Cl is 1 minus. You must have a positive and a negative to have a compound. So we know that Br is going to be the one kicked out because Cl is the one that's going to be coming in and replacing it because they're both negatives. So negative can replace a negative, positive can replace a positive. So in this case, Ca is going to combine with Cl. All right, so Ca was the 2 plus and Cl was the 1 minus. So when we swapped and dropped, we got Ca, Cl, 2. And then we have to also put on the Br, who's now by himself. He's a diatomic, so he's going to need that 2 there. Then when you go to balance the equation, you see you have 1, 2, 2, and 1, 2, 2. So it's already balanced. Okay, looking at another single replacement, again, we're going to determine the charges from the beginning. So we have 2 plus for Mg, 1 plus for H, and 1 minus for Cl. So Mg is going to kick out the other positive, which is the H. So Mg is going to get Cl, and it was 2 plus, 1 minus. So we're going to end up with MgCl2 here. And then H is going to end up by itself. He's diatomic, so you have to have a 2 there. And then we want to balance the equation. So we've got 1, 1, 1 and 1, 2, 2. So we're going to have to put a 2 here, and that'll get this equation balanced out for us. Okay. See another single replacement. Okay, here we have a polyatomic, 2 minus, that's carbonate, and then you have Na, 1 plus, and you have Al, 3 plus. So the Al is going to kick out the Na. All right, so we're going to have Al, 3 plus, combining with, excuse me, not an N, it should be a C, O3, 2 minus. So we're going to end up with Al2, CO3 parentheses 3. And then that Na is going to be out there by his side. All right, and then when we balance the equation, we have 1, 1, 2, and then 2, 3, 1. So we're going to need to put a 3 over here. It's going to give us 6 NAs and 3 CO3s. Put a 2 there to give us 2 ALs, and then we'll put a 6 in front of the Na over here. That'll get us all balanced out. Okay, another example. All right, NO3 is a polyatomic, 1 minus charge. Ag is a 1 plus charge. Cu could be 2 plus or 3 plus. Well, how do we know which one to use? Well, because it's not telling you in this instance, you can just pick. So we'll just make it 2 plus. Okay, so he was 2 plus 1 minus, so that's how that 2 got there. And then Ag is going to be by itself. So we're going to balance the equation. We've got 2, 1, 1, 1, 1, 1. So we'll put a 2 there, give us 2 Ags, 2 NO3s, and then I put a 2 here, gives us 2 Ags. Okay, all right. Now we're moving on to double replacement. Now double replacement, you can either remember swap the fronts, or you can just remember swap like charges. We need to figure out the charges though before we go doing any of this. Iron is in the middle, so he has different charges, but we see from that 3 that his charge is 3 plus, Cl is always 1 minus, K is 1 plus, and SCN is a polyatomic, thiocyanate, has a charge of 1 minus. So positive is going to replace positive. So you're going to get the Fe3 plus going with the SCN, 1 minus, and then that 3 is going to end up down there when we swap and drop. And then K and Cl, 1 plus, 1 minus. All right, and then we would need to balance the equation. All right. All right, so we have 3 CLs, so we'll put 3 over here, All right, now we need 3 Ks and 3 SCNs. So now the equation is balanced. Okay, another double replacement example. All right, here we have SO4, the polyatomic, which is 2 minus, H1 plus, we have Al, which is 3 plus, and F, that is 1 minus. So H is now going to go with F, 1 plus, 1 minus, and then the Al is going to get the SO4, 3. I'm going ahead and swapping and dropping now as I'm writing the equations. So understand where those subscripts are coming from. Okay, all right, and now I need to balance my equation. Okay, so I have 2 H's, so I'm going to need, all right, let's look at these first because these are definitely going to affect me more. All right, I'm going to need the 3 SO4s, which is going to give me 6 H's, 3 SO4s. Then I'm going to need to get 2 ALs, which is going to give me 6 F's, and put a 6 there, and we're all balanced out. Okay, all right, here's another double replacement. Remember to write your charges first, identify any polyatomics, and swap and drop as you go. Okay, and that one, because we had all 1 pluses and 1 minuses, there's no swapping and dropping involved. All right, this one looks intimidating because it has 2 polyatomics, but as long as you label their charges, you should be good. That lead is 2 plus because of that 2. So we're going to swap the positives, so you get Pb 2 plus and CO3 2 minus, so those 2 plus 2 minus cancel out, and then you get the NaNO3. Then you will need to balance the equation. All right, so on this side, and then on that side we all have 1s, put a 2 there, and that will take care of the NAs and the NO3s. Okay, all right, SN in the middle, so you get that charge from the outside there. AG, same thing. NO3 is a polyatomic, 1 minus, so we know that has to be 1 plus. And then we're swapping the fronts. Okay, and then we would need to balance the equation. Okay, so we got 1, 1, 1, 2, and then we got 1, 2, 1, 1. Okay, so we need 2 NO3s. It gives me 2 AGs and 2 NO3s. And then I need 2 AGs over here, and that gives me 2 CLs as well, and I'm balanced. Okay, we got the HCO3, which is 1 minus, the Na, which is 1 plus, the H, which is 1 plus, and the C2H3O2, which is 1 minus. So this will involve really no swapping and dropping, just swapping the fronts, just paying attention, which I'm obviously not doing at this point. Okay, so it's H3O, HCO3, and then Na, C2H3O2. And no balancing really needed because we didn't swap and drop anything. All right, last are the very easiest to predict because they always make CO2 and water. And then I'll leave the balance into you because I know those are the most fun for y'all. So always, 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 when you see a hydrocarbon, it's always going to be CO2 and water, no matter what. CO2, H2O.